pivotal, and that's my buddy Viktor Gamov. Hello, everybody.
Yeah, he's in Pivotal, I'm in Confluent, and we're going to be talking about Spring.
And Kafka.
Obviously, right? Oh, who here for some Kafka streams?
Who here has heard of Spring? Who here has heard of Kafka? Okay, well, this is not that talk. It's all about JMS, so settle in. It's going to be great. Okay. Oh, yeah, so the code.
Slides.
Lots of slides. Actually, it's here.
So basically, this is the only slide. This is the most important slide that you need to take a picture of. Take a picture and go grab this thing called GitHub, and everything is there. Works or not. If you're interested in code, ta-da.
It's gonna be there. It's awesome. We're gonna go through a lot of stuff. We don't have a lot of time. I asked for 3 hours. They gave us less. So we're gonna have to go as quickly as possible through everything that we're gonna talk about today, and sort of hope to finish it in time. And we've got a lot to cover.
Yes.
We're gonna go from absolute basics to all the way to
Kafka streams and Spring Cloud streams and all the things. So, like my buddy David Coverdale used to say, prepare your brain melt. So, we start with something that's like a premise.
Yeah.
Can we bring the black screen? Oh no, let's bring white screen.
Yes.
Let's bring your favorite place.
So we're gonna build a new software. The goal today is just to kind of take a look at data processing with Kafka. I think Kafka, it's dangerous to think of Kafka as just being another message queue, right? I don't think a lot of people, I think the people that are using Kafka successfully aren't using it because they can use it as a traditional like replacement for JMS or something like that. It's more that because it scales so well, it's become like a vein for data in the organization, right? It's become a way to move. It's not just about events, it's about the movement of data across the organization. And when you start to think of it like that as another part of your data layer, it becomes another kind of database, then interesting things become possible. It's not just about moving of small events that then trigger action on some database. It is the database, right? And so we're going to talk about that today. We're going to start with treating it as a message queue, kinda.
Yeah, kinda. And after that, we'll switch to more like a processing layer where we can do event-driven microservice type of thing, where you have a logic of processing data built in your application. Right. And the storage is separated and stored inside the Kafka.
Right. So, okay, let's build a simple application. We're going to go to my second favorite place on the internet, of course, after production, start.spring.io. We're going to build an application here called Kafka. And we're going to use a lot of different stuff. We're going to use Kafka itself, Lombok. We're going to use Kafka streams. And we're going to use Spring Cloud streams. So what we're actually using is Spring Cloud stream Kafka streams, which is a bit of a mouthful, but it works. Anything else?
No, that should be fine.
That should be fine.
Web maybe, but we really don't need to use it.
Or do we use 2.2?
No, we use it to like stable. Like you said, like we want to be in production. We do stable stuff in production.
Okay.
Yeah.
Good
stable
stuff. Generate. Whoops, I already have that there. Goodbye. Good. Hit generate. Okay. All right. And so the goal here is to build an application that actually, what kind of domain? What's a good domain here?
So here's the thing, like a weird thing to say, but I kind of love watch movies, and like these days it's all about the ratings of the movies. People go check the Metacritic, people go check the Rotten Tomatoes, people gonna check like Facebook for some opinions for some reason. I don't know.
Have you seen Avengers, the new one?
Yes.
Who's seen it?
So we need to scrap some of the spoilers that we prepared. So yeah, sorry about that. Next time. Oh.
What's Game of Thrones? Oh, I'm waiting for that episode, the next episode. Then I can start watching it, and I'll finally understand all those references. Anyway.
Yeah. So this is like about like a movie. It's not about TV shows. So it's about writing a streaming application that will generate ratings, or like we get the movies rated, and for that matter, we're going to be using Kafka.
Right.
Naturally.
And in order to use Kafka, the data that we're going to use, the data that we're going to move around in our system.
It's actually it's very enterprise format.
Right.
It's a pipe delimited text. Very enterprise format. How many of you guys and ladies from fintech or like banking industries? How many of you dealing with the streaming data in pipe delimited format? Right. Yes. So you guys do not need to be shy and ashamed about this one. We're all doing this. Yeah. It's okay. It's okay. Yeah. Yeah. So we essentially will take this data in the file format and we streaming to Kafka. We will add the velocity to this data from 0 to infinity. So, and to do that, we're going to be using some data that Josh will just bring this on.
Right. So we need to actually bring the data in. In order to bring it in, we're going to use a format called Avro, right?
Yeah.
Yo. Uh-oh.
Okay, so we need to remember like little weapon.
So we're going to use Avro and because
no pressure, man. I just yeah.
So because we're going to use Avro, I am going to bring in the support for Avro here. We're going to go to our little project, and we're going to open up the pom.xml, and we're going to do some terrible things to our dependencies. Whoa.
You mean in copy-pasting dependencies?
Yeah.
That's a terrible thing. It's like
this
is how we program things. There's not everything. Unfortunately, there is no start.spring.io for everything, right?
But there should be.
For, I don't know, for lunch or for dinner.
Start.lunch.io.
Yeah.
I'm all about the input. The output depends on what you eat, I guess.
Yeah.
So here's this. We're going to bring in the Confluent support for a schema registry. And by the way, we've got, what we're going to do is we're going to use a schema registry to store information about the type of data that we're going to conduct across the wire. We're going to use Kafka itself. Kafka requires Zookeeper. You've got a whole, just a whole zoo of crazy processes running that have nothing to do with what we're doing. And so in order
exactly, this is what the people like these days.
Right, it's great. So rather than doing that yourself, I found that I guess Confluent have this very handy little thing called the Confluent, what is it called?
CLI?
No, but it's a...
the Confluent platform. Okay, so the in Confluent, what we do, we're contributing to Apache Kafka project, and we're also one of the companies who has their own implementation of, not the implementation, but at least like a packaged version of Apache Kafka. And one of the tools that we're adding for developers who don't want to at least have their brains melted by, Zookeeper, Kafka, the schema register, all these things wired, we have a Confluent CLI that allows you to start different components. So what we will do, we will use the Confluent CLI and to start Zookeeper, Kafka, schema registry with one command.
Right. So I'm going to do Confluent destroy. Oh.
Yes, you should start every time with Confluent destroy. So this is very useful because you might have some of the leftovers from the stuff because Kafka remembers. Here's the reference for Game of Thrones fans. Kafka remembers. And this is why you need to wipe up stuff to start over. And that's why the Josh did a brilliant job calling my favorite command.
Here we go. So now we're going to start again. And schema registry depends on Zookeeper, it depends on Kafka, which depends on Zookeeper. So this is going to bring up everything required to start it. And so that's fine. I don't have to specify the other things in between. Okay, so that's going to start up. And now once that's there, I've got these plugins here.
Yeah.
And these plugins are going to convert a schema definition, an Avro schema definition, into objects that I can use. In order for that to be true, I need to have the actual schema files, and I'm going to get them from my source main resources Avro folder. So I'm going to just...
Reason for that is that we as developers were lazy. So it's much, much more better when you have someone or something to generate your Java objects. So we use this format of Avro as a contract, and we will use a Maven plugin to generate our Java Pojo. It's kind of sort of Pojo, but it also has a notion about how to serialize object, how to deserialize object, so it's a little bit more smarter than just a Pojo. So we're going to be using this kind of thing.
Okay.
For movies, we will have important properties of the movie ID, title of the movie, year, director, actors, genre, and so far and so on. So all these nice features we have in this Avro format.
So I've got the dependencies, but I need the plugin to do that. I need the Maven plugin. That's this thing right here. All right. So build plugins. Oh boy. Okay. Look at that. So there's the Avro Maven plugin. In order for all of that to work, of course, you need the right repository. So make sure you add that as well. Okay, so repositories. Okay, good stuff. And then from there, just do your one very small Maven clean install away from satisfaction. Here we go. Go, go, go.
So during this build, it will find this plugin will find these Avro files inside this repository in this like resources folder and generate all these classes that we'll be using for this for movies, etc.
So now I can do movie.java and
ratings.java.
Okay, so there's all that. Don't worry about it. Just look away. Okay, ignore the terrifying type. Now, what do we want to do? We're going to do two things. We got to get some data in there.
Yep.
And then we got to get some data out.
Yes.
But I don't want to. We're not just doing data in, data out. What we want to do is actually write data to the queue, to the broker.
Yes.
And then gather insight, to derive insight, to actually understand what the data means and how we can what we can do to process it. And we are dealing with potentially large amounts of data, so we're going to create a loader first.
Yes.
And then we'll use Kafka streams to process.
To make it more streaming type of thing. Right. So what we need to do in this case, we need to have this kind of the producer, the guy who will be generate some data. Mm-hmm. So we're going to be create the class that we'll call producer, where we will inject whatever beautiful things.
Should we do 2 Spring Boot apps? Yeah, 2 separate Spring Boot apps?
Yeah, just okay. two apps.
So I'm going to create a new package here called producer, and another one called analyzer, and we'll move this thing into there, producer.
Yep.
And it's all you.
Yep. All right. So with the producer, so what we're doing here is producer, right? So we have a class. We have a Lombok, so we can have all these beautiful things that Lombok does. What's the constructor?
We are required args constructor.
Yeah. Required args constructor. Logging is obviously we're doing log4j version 2, right? You need to type it log. Yep. Yeah.
Okay.
And obviously it's going to be a component, right?
Yeah.
So what we need to do in the real life, there's two classes, the producer and consumer. In this case, we're going to be focusing on the producer side of things here. But we're not going to be using this because Spring has even better thing that's called Kafka Template.
Right.
How many of you guys and ladies work with the thing called something template at Spring? So in this case, you know exactly what to expect. So you need to have this whatever we call it. Let's go. We have 2 topics to produce, and we will call this the movie producer and ratings producer. So in this case, we will have Kafka templates. First one will go with long is our type, and it goes with movie is our value. We will call it obviously movie Kafka template.
So in Kafka, you have a key for every message. And then you have the value of the message. So again, it's not like a message queue. It's not just a Java util queue that stores data. It's more like a map, right? You can actually index into the messages in the queue by their key. And so when you work with a Kafka template, you have to think about both the type of the key and the type of the value.
In order to make this work, we need to have some sort of the configuration. So
now where does the key come from, though?
Yeah, in this case, we need to have a configuration class. So can we use a configuration here?
Yes.
Well, so in this case, we'll just
another class, yeah.
Yeah.
Or in the Spring Boot Kafka application one.
We'll have a configuration. Well, we just put this here. So
yeah,
let's put the bins here. Yeah. So we will try to deploy this in production. Now, so for in order to work, we need to have this. Okay. So yeah, in order to work this, we need to have we need to pass the configuration.
Otherwise, it won't inject it. It won't create a constructor and it won't inject it.
Duh.
Just trying to help.
Yeah. Yep. So we will have the how it's called the
Kafka template producer
factory. Yes. Producer default. Where is it? Default producer factory. Yep. Default producer factory. So what it does, we need to return obviously something new. Default producer factory. So in this case, this guy also know a lot of things about Spring Kafka framework knows a lot of things about how to configure. So there's lots of things. If you're doing this local development, you don't need to provide like a local host type of things. But like in this case, we need to provide all this information because we're going to be using Avro, scheme registry. We need to provide information serializer, deserializer, things that George just mentioned, that a key in value will be serialized during the time where we're doing this, where we're passing through. So we have this map, something called config, map config, new hash map, and will be string, and will be string, and in this case we will do. Oops, I've almost like start programming Kotlin and always forgetting this like a thing at the end. Exactly. Yep. Exactly. Here. Why? So we will have this config will work. It's a live coding. So we will have this Bootstrap URL producer config.
Okay.
So we have this producer config and we have a Bootstrap URL. In this case, we will say it's going to be localhost 1992. We'll have here config thing put the we need to have a schema registry URL.
Yeah,
so in this case, we're going to be schema registry registry URL, and we need to have a HTTP. Obviously, in production, we need to do HTTPS localhost 1981, and two more things are responsible for producer config. Producer config, and we need to have a key serializer. Key serializer class. In this case, it's going to be the long, naturally. So in this case, there's plenty of those, but we need one for Kafka class. And another thing, since we're going to be using all this awesome stuff for Avro.
Is it the string name of the class? Is it the string name for the class?
It will work.
Okay.
So we have this the producer config and value serializer. So and we will have Kafka Avro Kafka Avro serializer. There's plenty of stuff, but we need to use only this one class. All right. So so we have this config, right? So we're passing this to default factory. Now we have two things, the config. So that potentially should be it in our configuration. The next thing that we need to do, we need to have a topic definition, because Kafka is dealing with this concept of topics, and topic is the entity that you distribute across multiple Kafka nodes. So cool thing is that the Spring Kafka integration thing, the Spring Kafka project has ability to create topics for us. So I think I missed. Bin. Okay. There's a class new topic.
If you weren't sure about what it is, it's
new topic.
A new topic.
So
it's very different from those old ones that JMS uses.
Topic. Topic, and we do return new topic. Oops. New. Again, it's also I blame Kotlin because I start just typing things. So the topic name, we have this topic with the movies, and it's a configuration that will be responsible for durability of your data, replication factor, and we're going to be doing very cool stuff here, meaning that YOLO. There's no replication.
So you're just going to replicate it to one node.
Yeah.
Oh yeah, that is YOLO programming.
Yep.
Yeah.
And we'll do ratings movies. Ratings topic, right?
Oh, sure.
And we'll do return new topic, and the same thing we do for ratings. So one of the things that usually developers do is pre-provision these topics before, or some operations people pre-provision. So the cool thing about this integration or this code, that you don't need to do a checks that if topic is existed, it will just use it, and we'll just use this definition and inject it here. If topic doesn't exist, it will create this. So, and it's a cool thing that Spring provides these capabilities.
It's like an upsert.
Yeah, exactly. So will it work? Because in this case, we have one default factory, and the Spring will be able to figure this out by type.
I think so. Only one way to find out, though. Let's run it. But I'm gonna if I refactor that.
Yes.
Just want to factor.
So I will be typing, Josh will be refactoring. Plus, so since we have this data in the format that is very enterprising, meaning this is text format, we need to do parsing. So we will bring a small thing called Parser after we will refactor the application.
I wasn't gonna be able to.
It's called severe case of OCD.
I won't be able to sleep otherwise. So, okay, it didn't.
No.
barf.
See, it didn't barf.
Yeah.
Scroll down, up. You see, this is Kafka version. So we on the right track. So
how do we see if those topics are there and all that? Is there a way to look at the database?
yeah. So you go to this guy. So do Kafka Topics, and there's a comment called list, and in this case we will have a zookeeper. Where is it? It has a zookeeper. So we do zookeeper, and we do localhost 2181. So magic. I think it's already halfway. We created topics without creating topics using just a Spring Boot. I think it's a good stuff.
Now we gotta
Parser.
Parser.
Bring the parser.
Oh, I'm just gonna copy and paste our parser into existence. Well, because it's not. There's nothing
springy about this parser.
Yeah,
You read the line and you do,
like, this is not code that you want to be proud of. It's just code that has to get written. Neither Victor or I are proud of this code. At no point when we wrote this did we say to each other, "Good job."
Well.
There was none of that. I don't remember. I was there. There was none of that.
All right.
So, I mean, it's nice that it exists, but I spent a lot of my time in the last.
It uses
2 hours.
streams. You see, it's a modern code. It's there's something to be proud of, right?
I just have to disagree.
All right.
I want to believe, but it just never got there.
All right. So bring the file in.
Okay.
So we need to read the file from somewhere. So in this case, we need to have
Sample
our
data.
endpoint for our application.
Okay, so the sample data is here. I'm going to reveal that in the Finder. I'm going to copy pasta this over here. Okay. Sure. Don't break. Whoa. So that's not a very big data.
No, it's quite a big because it has 900 lines of text. It's quite
That's
quite
all
big.
you're allowed to have.
Yeah.
Anything more than that, and
Not so much big.
the police.
Yeah.
Okay, so we've got that. Now we need to read that into a program,
Yep.
right? So I've got
Some
this.
Spring code.
Well, actually, I need to inject it, don't I?
Yep.
Oh, okay. So we have to get rid of that. Get that. Okay, but now I need a value for a resource. So value, and what did we say it was?
Class path, movie date.
Movie dot dat. This go here, that go there.
So in this case, we're going to be using this file, but in real life, the way how it works with the Kafka pipelines, either Kafka Connect will be listening this data from some legacy data source like database and pumping this data into Kafka, or it can be used the same producer-consumer to do the thing. So in this case, we will do old school way. We will read the file, or read the line by line.
Okay, so go for it.
All right. So I don't remember like how to read the file from this.
Copy and paste then.
All right. Where is it? Where is it? Just let's copy. Let's copy our method and save good stuff. So since like I said, we're not proud of doing the things.
Okay.
Yep. And this is what we do, right? So we're gonna do this. We're gonna do this. We're gonna be copy and pasting things. So so this is good stuff, right?
That was okay. Yeah, I was proud of that.
Yeah.
It's like good job. I did say that.
So we'll do import on demand. No. We're reading this movie file. And do we have a right version of Java? Probably, yeah. So movie template. Do we have it? We can call it.
Yeah.
Let's call it.
Sure.
As we have it here, right?
Okay.
Movie template.
Have to set the variable.
Yep.
Up.
Up.
There you go. Assign it to the right thing. Good stuff.
Okay. All right. So next one. Where's our template? Where is it? Why it doesn't work? A movie topic. Okay. So movie topic is some of the constants that we also will copy because this is cool stuff. The two names of the topics. Usually we're using the Spring Boot configuration and things like that to pass this kind of configuration.
Yeah.
And if you're running this in some sort of
you know what would have been interesting? Just yesterday, that's Wednesday, for those of you not keeping track, I released a new Spring Tips video. Every Wednesday there's a new video, and yesterday I introduced how to use Spring Batch to process large amounts of data from Kafka for ETL, exactly like what we're doing here. I really think I should have brought that up before we got on stage, though. It might have been a different talk.
Spring Batch, not the Spring Stream.
No, comma.
Oh, comma. You're injecting this one over
Yes.
here. Why it is
Movie
not?
files is called curly braces.
Where?
Huh? You say that. Oh, it's not assigned to anything. That's fair, yes. Great point. Good stuff. He's been writing a lot of Kotlin, and so in Kotlin, the constructor is the storage. Yeah.
Don't, yeah, just
So
don't,
create a
yeah,
source
yeah.
variable.
Yep.
And then you're going to see when I do my next talk, I'm going to be doing it with Ray Tsang, and he's been using Vim or VI a lot.
He's gonna be struggling with
Yeah.
your code. Why it is doing this? Why it is doing this?
Okay.
It's not.
There you go. Almost there.
Oh.
Sweet nectar.
Okay. Good.
All right.
Okay. Good. Oh, okay. Template. Template. We have a different name, right?
Yeah.
And go.
Ooh. Good
So
stuff.
as you can see, this the how we call it, all this like a framework programming is basically just juggling around with some copy pasting things.
Yeah.
This is what you find in the internet, and just you copy paste. But
Stack Overflow oriented programming.
exactly. So two things. So we do have our template for movies. We will use this to produce this data. This method has different variation. If you like more like a asynchronous style of programming, there's like completable future or like a listenable future that can be turned into completable future. Now,
Should we run it?
oh yes,
I want to run it so bad.
let's do it.
Okay. Okay. Let's see. How do we test if this works?
We have a Confluent CLI. Remember?
Well, cannot resolve movies.dat. But I disagree. I think it's right there.
It's there. Just run the build. Just remove this guy. Just remove. Yeah. Movies, and yeah, movies.
Movies.dat.
No. That's fine. Yeah, perfect.
All
Yes.
right. Good stuff. Go, go, go. Stream with the speed of...
Speed of love.
Okay. Cannot be resolved.
Remove these two dashes.
Like that?
Yep.
Think that's going to work?
Yes.
Oh, yes, that'll work. Okay.
Yeah, that will work. All right.
Good
All right.
stuff. So now
So
let's-
Confluent CLI. Let's see if we actually have something here. So we do. Where's our terminal? We do Confluent.
Make it bigger. Make the font much bigger. All right.
Writings. Oops. Writings. Right.
Yeah, sure.
And we should see some stuff.
Yeah, good. Okay, so now we've got stuff that we can process.
Data is streamed, but 1 second. People were saying, "What the hell? What is that?" I will tell you, because we didn't specify value format. Now, behold. Just one check and you see everything differently.
So
Okay.
what, you said format. You said
Yes.
back
So
to it again?
yes. So the reason for that. Okay. Yep. Terminal. We need to do it because it's a full screen. Swipe. Yeah. So reason for that. So we start reading the data from or generating the data in our Java file, and after that we send this data to Kafka. Here's the thing: Kafka really don't care what kind of stuff you will put in there. Some people even put files there. I'm not saying this is a good idea. Probably, if you start putting the files in Kafka, you need to consider your life choices in general. So, but I'm not the one who judge. So the thing is, we actually try to, with the binary format, we're trying to simplify and reduce payload. So that's why you would see this output of this binary data, because console will not be able to read this out. And things like the Avro is a binary format. Another thing, we store schema not as a part of our payload. So in this case, our payload becomes even smaller, and we don't store the schema with every message. So next time, when you try to read this, schema registry will return this, and it will be also locally cached inside your application, return the schema, and the serializer, because the binary payload knows how to deserialize itself, will just be invoked and will bring stuff in. All right, so we have a data in. Now we need to start doing some processing.
Right, so I'm going to use Spring Cloud Stream's binder support. So Spring Cloud Stream is a project, 10 minutes?
20. We have plenty.
Spring Cloud Stream is a technology that allows you to describe messaging brokers in a generic sort of fashion. You can extricate the wiring, the routing of these brokers into the config files, and then Spring Cloud Stream materializes the thing that you need to actually talk to that broker in an efficient way. So one way is to use the Spring Framework message channel abstraction, and this allows you to think about downstream brokers as just being things at the other end of a pipe, the same kind of pipe that you would see in Spring integration, right? So when I say pipe, I do mean to invoke the idea of a pipes and filters architecture. On the other hand, if you're using Spring Cloud Stream with Kafka streams, you can use types that are more natural for people working with Kafka streams. And in particular, in Kafka streams, you have two ways of thinking about data. You've got
Let me stop you right there, because some people might don't know about Kafka streams. How many of you heard about Kafka streams? Oh, okay, continue.
So Kafka streams.
Kafka streams, it's just a library. It's a part of Apache Kafka. It's an embedded framework for stream processing. That's it. It's nothing more. So that's why it fits very well in the notion of dealing with Kafka or with a Spring Boot. Just another job.
It's a stream processing pipeline, but when you're working with Kafka streams, you can build processing pipelines. And for me, the reason I became interested in Kafka streams was I wanted to do a lot of the things that people might otherwise do with something like Spark. I wanted to have that kind of functionality without having to deploy and manage Spark. So I was looking for something that, I want as much functionality as possible without having to pay that complexity cost.
Go to software and figuring out where your app is running, how to store your state, like how you would submit this job, how you would do with some complex pipeline, and how to recover and all this stuff, right?
So Kafka, as long as you've got Kafka in your organization, you can use Kafka streams. Kafka is all you need in order to run this, and so you can just write the code in any language that Spring Boot's. I can use Spring Boot plus Kafka streams very easily, and that's it. So anything that supports Spring Boot, Kotlin, Java, Groovy, whatever, Scala, anything that works just fine. In the world of Kafka streams, you've got two types. One is called a K-table. What's a K-table?
K-table is the representation of state. So there's the two type of things that you might have here: history of the things and the state of the things. So the state of the things, meaning that we can query this table and can say we know that, for example, movie for a particular movie ID with this moment of time has this particular value. Yeah. The second one is obviously Kafka streams, which represents the history. It represents all facts that happened within a particular time or whatnot. So essentially what it does, it maps into Kafka streams, maps into Kafka topic, and the Kafka K-table maps into compacted topic. So compacted topic is a special type of storage inside the Kafka that stores only latest and greatest value for a particular key.
Right.
And another thing, I just want to mention this because you mentioned different languages, and I want to mention a little bit of assembly language here. So things like a consumer, producer, and a little bit of the Kafka template is what we consider as a kind of low-level APIs. You're dealing with these, like sending messages, individual messages, where Kafka Streams is more like allows you to deal with the functional approach. The Kafka Stream has two types, two fields. It's a DSL, which looks like a Java 8 the Stream API. There's also Parser API. We're not going to be touched this in this talk, but it also allows you to build very complex data pipelines.
So when you work with Kafka Streams, and with most messaging technologies, you have to think about, there's a lot of things you need to care about. First of all, to what does this thing connect? And also, since I'm writing generic Java code, I'm using a binding, okay? So this is an interface here. This interface defines the bindings that I want Spring Cloud Stream to manage for me in my Spring Cloud Stream Kafka Streams application. So I'm saying, hey, Spring Cloud Stream, I've got this thing, this topic called movies. And now this is a logical name. I'm just giving it a logical name that I can understand in my code. That mapping from logical name to the actual broker is done in terms of configuration. And so you can see here I've got movies as the logical name. And in the configuration here, I've got movies. So it says Spring Cloud Stream bindings.movies. And then I specify things like the application ID. I can specify things like the destination in the broker, the actual topic, how we should encode headings, headers, how we should do decoding. All these kinds of things get specified in configuration. I don't have to worry about all this because it's done in the property file, and that can live in the config server, for example, in Spring Cloud config server or somewhere else. It doesn't have to be in my Java code where it's much harder to understand at a glance, and it's also much harder to change.
And obviously in production you might have different URLs for scheme registry, for Kafka Bootstrap server, so this information can be externalized and injected during runtime, during startup.
Well, it should. So,
yes.
So we've extracted that out. Now I'm just saying basically, hey, I'm expecting to get data, and I want to work with it in terms of the Ktable API from the movies topic, okay? I've got data in the ratings topic, and I expect to work with it as a K-stream. I've got data that's going to be coming in from the average table topic, and I expect to work with it like this. And then finally, I have two outputs. I expect to send data to these K-streams, okay? So these are, I can get a hold of these references. They're fully initialized for me by Spring Cloud Stream, and I can just start working on the data that's coming off of them, or I can start sending data to them, okay? Now, in the case of the output, you don't actually grab a hold of a reference to a K-stream and then send anything to that. In
this case, it would be not a Spring Boot way or Spring Cloud way. So we're going to be using dependency injection here.
Right. So now, we're going to do two things. I think the first thing is we're going to tell Spring Cloud Stream to make it so, and we'll do that by saying @enable bindings. So here we go, .class, and then we're going to create I think the first thing I want to do is process the data that's coming from the
Do we want to enable Kafka Streams as well?
No, it's already done.
Okay.
Should be done.
Yeah.
Hashtag YOLO.
Yeah. So we're going to be using like a very sophisticated algorithm to figure out the movie rating. So there's different ways how to do this. We're using the most sophisticated one. So we're getting count of the ratings, and after that we do sum of this rating, and after that we divide sum by count.
Right. So I'm going to create a stream listener. This is a Spring Boot component, regular Spring Boot component that's going to listen for messages coming in on the ratings topic. Is that true?
Yes.
Okay, so bindings.
In this case, we really care about the stream of ratings because another application, another microservice, if you like, will be pumping data in. So we're interested in all events that happen. The story with movies is a little bit different. We're talking about movies when we will touch base on this kind of thing.
Okay. Yep.
Yeah. And as always, we have
rating. Okay, so that's a long and a rating incoming ratings.
So interesting thing here that's
oh yeah, public void process. Okay. And
interesting thing that the Kafka, Spring Boot or Spring Cloud Streams will be handling all these low-level things, including Spring Streams Builder, building topology, starting Kafka Streams application. Everything will be handled. So in this case, you're only focusing on this thing called topology. So basically, things with K-stream and K-tables, you're building a topology of your application. How many of you folks have here a PhD in maybe graph theory? Anyone? Okay, so I can be smart for a couple seconds. So here's the thing. There's a thing called directed acyclic graph. And it's not just a simple graph. It's the to-be-directed, meaning that it has a beginning and the end, and acyclic, meaning that there's no loops in it. So this is model that you use to explain or describe any data pipeline. So basically, Kafka Streams API provides you the way how you build your directed acyclic graph. So it's cool that there's no like a PhD in graph theory here, so I can say.
Right, that's fair.
Perfect.
That's fair.
So the cool thing is that this application, the Kafka Streams, provides the way how we can describe your topology. So you can grab it and use the visualizer tool to see this graph.
So what I'm doing here is I'm going to say, when the data comes in on the K stream, I'm going to reduce it. I'm going to turn it into a grouped stream of, oh, that doesn't seem right, does it?
No, it does right.
Okay, it's going to be a group stream of ratings. I'm going to take all the ratings and then group them by the key, right? Then finally from that, I'm going to create another K table out of the count. Then I'm going to do a reduce here by adding them together. Is that right?
Yes. As you can see here, we transform in one stream into the group stream, and after that, we transform group stream in the K table because we're interested in the state and the way how we collect in state, the count and the sum is the way. Because the K table has this method. So ratings stream.count returns a K table that will have all information about particular key and the running sum. And one of the things that you probably will notice and will not notice in this code, there's no way how we can specify storage, like if we're using database or we're using a file or we're just storing this in a hash map. So all these things is handled by Kafka Streams. Kafka Streams is the framework that provides you ability to do stateful stream processing, meaning that when you're calculating things like sum or you do count, in order to calculate the current step, you need to have a state from the past, right? So, and Kafka Streams got you covered. So it has a variety of state stores. It can be used persistent state store. In this case, it will be a small instance of the RocksDB that will have all this information. It can be in-memory store. There's API how we can implement your own store. And cool thing about this state store, it's also replicated through Kafka. So if the application will breaks, it will have a changelog topic inside the Kafka. So next time when you restart this application, you don't need to reprocess everything. You can retrieve the state from the Kafka.
So if that's working,
yep.
Let's run it. What should we see?
Right. So what did you do?
Good point. Map the values. Did it count? Woo! Trying to prepare, blah, 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 blah. Case stream. Oh, see, we've got some things that aren't being used yet. So we want ratings. We don't want movies just yet. And we don't want average and average ratings yet. So we've got ratings and...
Ratings in, and we need to have a ratings out.
Oh, we need average ratings. Yeah, there we go.
Yeah.
That's correct. Okay,
yeah.
Let's try that again. Nothing is bound to those things yet, hence it's not going to work. Okay.
Something happened. There was a red thing just flushed.
Oh,
yeah.
Yes. Look at that. Serialize. Oh, we need to materialize the data. So again, we're going to be processing data in this pipeline, but in the intermediate steps in the pipeline, it's going to write data to the database. And so you have to materialize the data. And this is the part that, it's kind of easy to do it afterwards. So you have a materialize with long, you have serialize.long, right? Like that. And then serialize.double. Now serialize is a serializer, deserializer pair, okay?
So again, it's a Java framework that's dealing with object, but the Kafka is dealing with binary. So every time when we need to save something into Kafka or save something outside, we need to bring all this kind of fun and cute stuff like serializer, deserializers. And there's like a helper classes that allows you to retrieve serializer for particular type, like all these like standard types are supported. Avro supported also, like out of the box, there's specific Avro serializer that able to invoke on this method to deserialize this stuff.
So I'm going to run this. I'm going to run the loader.
Yep.
I've got this thing running, and now we should be able to go do what on the command line?
So first of all, remember what's the topic we're using to store the data?
Well, that's average ratings.
Yes.
Right?
So we can listen to this topic and see if we have anything in this topic.
So average ratings is called AVG ratings.
Yep.
Alrighty.
And just erase everything because the value format is in this case it's not Avro, it's just a Java format. So we would see very beautiful things. And actually, this you know what's that? It's how the Java serialization look like the standard Java serializable. It's ugly, right? So this is why we're using cool stuff like protobuf. We're using the Avro. We're using thrift. We don't using because it looks ugly, right? So
well, That's one reason, I guess. Okay. So that's clearly doing something, right? It's writing data to that thing. Can we turn it into something more useful, or is that the only way?
No, in this case, it's not useful because we don't interested in these results.
Okay.
In this case, our this like a generic command line tool need to understand Java serialization. We need to bring the classes and all this nonsense.
Okay, so now we need a ratings processor.
Yes,
okay.
For movies. So we have these ratings averages, and the way how we will be doing this, we will be joining two streams, right? So that's why you have two persons on the on the stage. How many person you need to join two streams?
More.
Two.
Let's see. So So we're gonna say first things first. Public void process incoming movies. I'm gonna have two. We're gonna input two different things here. We're gonna have bindings dot movies, right?
Yes.
And that's going to be a case stream of long and movie.
Yeah.
Movies, okay. And then at input, and we don't want the movie itself this time. We want the
average ratings. Yeah.
Yeah, the output. So it's going to be bindings dot average table or average ratings. Yeah, I guess that. And we want that to be a case stream as well. That'll be a long of type double. Is that true?
So in order to us not to go to Kafka every time for read this rating, because we have two separate processors, kind of sorta, this processor also that the moment where Josh did materialized, it actually created local local state. So we can retrieve this from the local state. So this is why we're injecting actual table.
So
it's going to be
ratings.join.
Yeah.
Other way around. Okay. And then ratings.join movies.
No. Movies join.
Movies.
Yeah, we're joining movies. Yeah, movies that join ratings.
Totally different.
And
new value joiner.
Yep.
Okay. And the input is going to be a movie and a double, and the output is going to be a rated movie.
Yeah. Which we don't have.
We create it by creating a new rated movie, which I copied and pasted earlier. That's this. There you go.
That's convenient.
This thing right here. Okay. So I'm going to create a new rated movie. It's going to be movie.getMovieID. It's going to be movie.getReleaseYear. It'll be movie.getTitle. And then finally, the double, which is the rating. It's the average of the ratings from before. Okay, so what's happening? What's wrong with that? Seems okay. Movies.join, new value joiner. Is it?
Yeah.
Where is it? What's wrong?
Just a second.
Okay.
What's the error?
No idea. If I knew. Isn't it the other way around?
Long. Movie.
Is that not a double?
No, it should be double. Yeah.
Long double. Okay.
Let's bring our working code.
Sure. Always good to have that, just in case. K-table.
K-table. Yeah, this is what we need to have a
long movie.
Yeah.
Long double.
Yeah, but you have a stream,
average
I guess.
table. Oh, it's K-table.
Yeah.
Right.
Hmm.
Okay. Wait.
It's this one.
This one.
Yeah.
Yeah. And this should be average table. Then.
Yep.
Okay.
All right.
So
we have we need to have put it back into Kafka. So in this case, we need to have a return case stream.
Sure. Okay. Let's see. Where's our thing here?
Yeah, it's over here. So when you have a join, over here. Yeah, we have a join. So it's
Sure.
extract the valuable from. Yep.
Join, return, join.
Dot
this.
to stream.
Okay. And then it'll be send to. And what will be the send to?
Rated movies.
Rated movies. That's the final product.
Yep.
The final thing. And in order to do that, we're going to say join.toStream. Is that true?
Yep.
No, not at all.
It's a key stream.
Dot to. Wait, what? It's a K-stream, yeah.
No, it's a key table. The join
so it should
returns.
be the other way around then. Should be
it returns key table. Key table, a join to stream.
Oh. Nope. I think it's the other way around. I think we do the ratings.join movies.
No. 1 second. Scroll up. We'll have movies. It's also key table.
Oh, okay.
Key table. And in this case, it returns right thing. And we'll do how you extract the variable.
Command Alt V.
Okay. No, wrong one. The at the end, right?
Okay. Good.
Oh, see what I did this.
Okay. Good. Alrighty. Sweet. Okay.
So We still have 1 minute.
Let's
so
see if that works.
Just run it.
Okay. So what's that going to do? Let's just run it and see.
And we can see result in.
Let's see if it goes. Happy. Okay.
Just do not a different one. The rated
movies.
Yeah.
Is the loader running?
Yeah. Loader running.
Kafka application, that's this one.
Yeah.
I didn't restart analyzer.
Yeah.
So that's the Kafka application. Restart the analyzer, which doesn't know about this new stuff yet.
Yep. The
rated movies, a component required of being named rated movies. Oh, we have to enable that binding. So here's our analyzer.
I think you.
Yes.
Yes.
We need that. And we need this. Take two.
Movies.
Movies?
Yep.
Oh. Alrighty. Ready. Steady.
Nyanket. All right. So to break this the awkward silence, I need to probably say maybe some jokes and stuff.
No. Okay, hold on. Wait for it. How do we know if it's working? Stop it. Okay, let's see. What are we missing here, sir?
See output.
There we go.
Thank you very much. Josh Long, ladies and gentlemen.
Great job, Viktor. All right. So, what did we do? We started with basic Kafka. We started with a Kafka template, sent messages into the broker. That's all very well and good. If you've ever used a template before, that should be fairly obvious. We then moved straight into the deep end of the pool and started using Spring Cloud Stream to abstract away some of the configuration and the routing. And then we used Spring Cloud Stream with Kafka Streams to do distributed stream processing at great scale. So here it's just a small finite data set. But of course, the whole point of this is that you can now build pipelines that handle, Netflix scale kind of stuff, right? So that's a real opportunity. All right, thanks everybody. Enjoy.
Yes.
Good show.
And as always, we're available for advanced interrogation.
Yeah.
Absolutely.